Thank you very much, Jesus, and thank you very much for thank you very much for inviting me to be with you today. It's a great pleasure to present to you some of the key changes which we made in future Eurocode 2 compared to today. Now, you see here my table of content. As you will see from this, I will focus on the part 1.1. The fire part 1.2 will be presented in a separate presentation. And obviously there is a lot of information, so I will have to go fairly quickly. I will use the projection. Yep. So I will test your capabilities of mutual or how should I say, multitasking. I will give you some of the information and I'll let you read other things which I have on the slides in parallel. Now, of course, you're aware, I mean, we have the first generation of Eurocodes, which is still in force. That has total 10 Eurocodes, total 59 parts, quite a large volume of pages, and more than 1,000 so-called nationally determined parameters. These were published between 2002 and 2007 and have reached a very high relevance of course, in Europe, in the countries in Europe. But as you can see from this map here on the screen, also outside Europe, Eurocodes have acquired a lot of interest and have been adopted by a number of countries. Now, already 5 years after the last Eurocode of the first generation was introduced, the EU and EFTA decided to and issued a mandate for the revision of the Eurocodes. They assigned that to CEN, and inside CEN, this was assigned to the Technical Committee 250. The main objectives of this revision were to improve ease of use, because there were concerns by a number of countries that the first generation was not so easy to use, and definitely Europe wanted to have a reduction of the number of these nationally determined parameters to avoid trade barriers in Europe. The initial drafts of these revised Eurocodes, they were drafted by 73 project teams. They were contracted under this mandate, and they worked in 4 phases. You see these 4 phases here shown on the slide in green. First one started end of 2015, and the last phase ended beginning of 22. During that entire time, the subcommittee responsible for a specific Eurocode, of course, was working in parallel. Subcommittee providing input for the start of the work of the project teams, reviewing intermediate drafts, and taking the final draft of the project teams and developing them further and preparing them for CEN inquiry and formal vote. The CEN inquiries, you see them in these yellow bars. The earliest started in late 2019. Oops, and the last one is planned to be held before the end of 24, and formal votes slightly staggered. First one in 2020, and the last one is planned to be held before the end of 25. Once a Eurocode is approved in the formal vote, CEN will do some final editing work and then makes these standards available to the national standardization bodies, who can prepare the national annex and then publish these standards with the national annex as a national standard in their countries. Now for Eurocode 2, you see the key dates there marked with the square and EC2. So for Eurocode 2, the formal vote was this summer, and we expect to have these revised standards available from CEN any day now in October. I have tried to find out and hope to get some answers today so I can communicate hopefully a little bit more exactly when in October this should be happening. Once country the country can publish these standards with the national annex at the time convenient to the country, so as quickly as possible if they want, but Sen has given a latest date by when this has to happen, and this is end of September 27. That's the latest day when it has to be done. And any conflicting standards, in particular the first generation, will have to be withdrawn latest in March 28. I'll show you here quickly how we organized ourselves to do this work under the revision of the Eurocode. We had the subcommittee who is responsible for strategic guidance, supervision, decision-taking. We created a working group 1, which was responsible for coordinating all the technical work, doing editorial work, and of course, holding technical discussions. And they again created 10 task groups and 3 ad hoc groups to work on specific technical topics and to prepare technical input as the basis of the work of the project teams. We had 3 project teams. Team 1 was responsible for drafting part 1.1. Team 2 was responsible for drafting the part 1.2 prior, and Team 3 responsible to draft annexes for new materials, which were integrated then into the part 1.1. And finally, we created a so-called coordinating and drafting group, which did editorial work to prepare the documents for inquiry and formal vote. I show this slide in particular to really express my very sincere and great gratitude for the work done by all these experts involved in this work. They have done a great work, a great job, and it was really a pleasure to work with all of them. And we have highlighted here in this slide our Spanish colleagues who have been involved in many of these groups and very significantly contributed to that work. And as it was said, this slide here represents the status up to formal vote. And since summer now, Spain has the chairmanship of SC2, and Alejandro is since August the new chairman of SC2. Congratulations again. Huh? Here you see the table of content, which of what I call the main part of Eurocode 2. Those are the clauses 1 to 14. If you look at the title of the clauses, it's basically the same as in today's Eurocode 2, part 1.1, except that fatigue has now a separate chapter. I have marked here in colors, in green, the clauses where I will give some information, and in yellow, those are clauses which will be presented in detail by other authors and presenters today. Overall, you see this main part has about 250 pages. If I deduct the introductory clauses 1 to 3 with definitions, it means we have about 180 pages for the main design work for concrete structures, so a volume which in my opinion is quite reasonable. On top of this, what I call main part, we have quite an extensive list of annexes in which we give additional information to other materials and other topics which perhaps are not so regularly used. Marked in bold here on this list are topics which are new compared to current Eurocode, which are not covered today. And again, this color coding is the same as before. So overall, the future Eurocode part 1.1 will have overall about 400 pages. We took some important decisions at the start of the work. First one was that we wanted to have design provisions which are based on physical models, independent of the type of member. These models should be sufficiently detailed that we can deal with existing structures to avoid unnecessary strengthening, but they should be able to be simplified so they can be easily used for design of new structures. Since these models are independent of the type of member, we anticipated early that we will have few clauses left specific to bridges. This is why we decided to integrate the content on bridges, not keep it in a separate part, but integrate a few provisions left for bridges into an annex into the part 1.1. And we took a similar decision for the current part 3 on containments, and also decided to integrate that information into an annex of part 1.1. We also took some decisions to try to improve sustainability of concrete structures. In current Eurocode, typically the strength of concrete is defined at 28 days. In the future, we allow to specify this as so-called reference age. In many cases, that may perhaps remain at 28 days, but we have offered now the opportunity to increase that reference age up to 91 days so that we can benefit from the strength gain between 28 days up to a maximum of 91 days of concretes which have a slow strength development. And this, of course, is in particular important for so-called green concretes. We have also introduced a new concept for durability assessment, this exposure resistance concept. This can be used for any type of concrete, but it has again been introduced specifically to be able to have a tool for new concretes which come on the market, for which we have not enough experience to have really reliable deemed to satisfy rules. This will be presented in a separate presentation. We have also introduced provisions for structures made with recycled aggregates, and we have introduced also an annex for the assessment of existing structures to hopefully try to keep those existing structures alive as long as possible. Now, a few words to these to individual clauses. Clause 4, that's basis of design. That's where we give all the basic assumptions. And in particular, we give here partial factors for actions specific to concrete structures and the partial factors for materials. As you can see on this slide, we have collected them all in these compact tables. So no searching through the text. You find them easily in one compact table. To the left, just as an example shown for the pre-stressing actions, and to the right for the partial factors for materials for the different design situations. Worth noting here is the new partial factor which has been introduced, gamma V, for shear and punching, shear resistance without shear reinforcement. We have introduced this because we recognize that this partial factor depends less on the concrete strength and more on geometrical conditions, and therefore warrants a different partial factor, and you will hear more about this in a later presentation. Clause 5 on materials, that's where we give only the material properties which are directly needed for design, and only for the most commonly used materials. For other materials not so often used, yet at least, or other properties which are not directly used in design, we have moved all this information to annexes. Few words to the main materials. Concrete, we have increased the maximum compressive strength class to 100 MPa cylinder strength, and we have modified the definition of the design strength. Today it's alpha cc times FCK divided by gamma c. And you see we have replaced here the alpha C now with two coefficients. KTC is a coefficient to consider the effect of sustained loads, Ruche effect, and eta CC is a coefficient to consider the increased brittleness of higher strength concretes. You see the formula for this coefficient eta CC over here. It is as you can see, up to a recommended value of 40 MPa strength, this coefficient is always 1. And if you go beyond 40 MPa strength, then this coefficient gradually comes down and reaches about 0.75 at the strength of 100 MPa. I will tell you later on what the advantage of this is when I come to clause 8. Also in clause 5, we give values for total creep and total shrinkage in a very simple table, so the user can find values, total values, after 50 years very easily and very quickly. If, for whatever reason, more detailed analysis is needed or somebody wants to really go into the detail, we give all the formulae for creep and shrinkage in Annex B. These are based on FIB model code, and so very detailed investigations can be done. As a general comment to creep, if you compare the values of creep to the new model, to the new Eurocode, They are quite similar to the values given in part 1.1 today. This is not the case for shrinkage. There we have larger differences. The shrinkage value in the new Eurocode will be higher than in current Eurocode. And this has caused quite some discussion during the development. And this is why we have introduced an NDP value so that countries can consider the use of specific types of cements and aggregates in their countries to adapt these shrinkage values if needed. Reinforcing steel, also here we have increased the range of strength classes up to 700. Similar for pre-stressing steel, a slight increase for strand. Otherwise, design assumptions are the same. See here the stress-strain diagrams for design, that's the same as in current Eurocode. We have a slight issue because there are no commonly accepted standards for reinforcing pre-stressing steels at this time. So that's why we make reference to so-called relevant standards when we refer to these materials. This allows the countries to specify the standard which applies in their country at this time and until harmonized standards will be available in Europe for reinforcing and pre-stressing steels. Alternatively, rather than referring to a standard, countries can also give the properties directly in the national annex. Clause 6, this will be presented in a separate presentation, so I do not go into this. Clause 7, structural analysis. As a first thing there, we have harmonized the provisions for global imperfections to hopefully simplify the work if you design, for instance, buildings which have concrete members and steel members. We have slightly modified the formulae for the amount of redistribution which you can allow in linear elastic analysis without an explicit check of the rotation capacity. And we have added new provisions which allow you to calculate explicitly the actual rotation capacity. Clause 8, ultimate limit state, a few words about bending with and without axial force. Here we have first of all simplified the strain distributions in compression. We now allow for all these compression states to reach epsilon Cu. We also give just unique values for epsilon C2 and epsilon Cu, the ultimate strain of concrete, identical values for all strength classes. So this should, in my opinion, simplify the design. And why could we do that? Because we have now considered the increased brittleness of the higher strength concrete on the strength side. So not on the strain side anymore, but on the stress side. When you use these assumptions shown up here, you can calculate these interaction diagrams, which you see here on the slide. Solid curves are the new Eurocode. The curve most on the inside, this is the interaction curve when you do not consider any effect of confinement reinforcement. And if you consider confinement reinforcement, you get outside there with these solid curves. Also shown in this slide are in dashed curves the interaction diagrams of current Eurocode. As you can see, the new Eurocode, we are somewhere in between current Eurocode. The inner core of the current Eurocode is with alpha CC equal 0.85. The one on the outside, alpha CC equal 1. So new Eurocode somewhere in between. If we consider higher amounts of confinement, we can even go beyond. Also interesting is if you look at the interaction diagram for parabola rectangle and for stress block to the right here, you see to the new Eurocode, they are basically identical, which is not the case in current Eurocode for whatever reason. Few words about confined concrete. We have amended these provisions. We give the simple provisions up here if you have a member which has a uniform confining stress on the entire cross-section. But in practice, of course, this does not happen with the cross-sections and the layout of the transverse reinforcement. So for these practical cases, we give these coefficients K, which allow you to calculate an average, a smeared value of the increased strength, which is valid for the entire compression zone. These values of the coefficients K are given again in a table. Shear and punching shear will be presented in separate presentations, as will strut and tie models. On partially loaded areas, we started out with something a bit different, but we ended after discussion to go back to what we have in current Eurocode with the same limit of 3 times the uniaxial strength, unless somebody does a more refined analysis, including tensile stresses due to loads or restraints. We have changed the definition of the contributing area, which now gives a nice transition from 3-dimensional load distribution to 2-dimensional load distribution. Serviceability, cracking, and fatigue, again, will be presented in different presentations. Clause 11, detailing of reinforcement. A few words about minimum mandrel diameters to avoid damage to reinforcing steel. No change, that's what we have today, but we introduced some new provisions to avoid damage to the concrete inside the bends of bars. We give conditions where no such check is needed, and that covers many or most of the cases in practice. But for special cases where you need to check, we give a detailed formula here, which allows you to make sure that you do not crush the concrete inside tight bends. Main part of clause 11 will be presented in a separate part, and then at the end of clause 11, we have some additional provisions for post-tensioning tendons and deviation forces due to curved tensile and compressive cords. Clause 12, that's detailing of members. There we define the minimum reinforcement which you need to provide so that the design models which we give for ULS design are valid. So we give that as currently also we say that the resistance of the cross-section with the minimum reinforcement must be at least as large as the cracking action of the cracking resistance of that same section. However, for members where the action effect does not cause cracking, we give this this provision here to the right, where we allow to provide lower amounts of minimum reinforcement, such that the resistance of the section with this lower minimum reinforcement exceeds a factor times the applied action effect. This coefficient K goes from 1.3 for reinforcement ductility class A, so low ductility, down to 1.0 for ductility class C, high ductility. Detailing rules, then the main part of clause 12 is detailing rules for members. We have collected all these rules in these nice compact tables, so you find them all on one page. Easy to find, easy to see where the data or the information is. We give here show here the table for beams, and we have similar tables for slabs, columns, walls, and so on. We recognize that practice varies quite a bit or can vary quite a bit between countries for the detailing, and therefore we have made all these tables an NDP so the countries can adapt these or modify these tables as needed. Clause 13, precast elements, structures, basically that's the same as in current Eurocode clause 10, but we have moved the provisions for pre-tensioned concrete from the current section into this clause 13 because we recognize that pre-tensioning is mainly used together with prefabrication. So design detailing rules now in clause 13 for pre-tension tendons, and there we have changed one provision in particular I want to highlight here, which is the verification of the shear resistance with the principal stress criteria. We have limited the use of these provisions now to members of a maximum depth of 500 millimeters. If somebody wants to use this for taller members, they will have to consider the size effect in a refined analysis. Clause 14, plain, lightly reinforced concrete structures, basically the same as we have today in clause 12. We have, however, changed slightly here this we have changed this coefficient phi for the simplified design method for walls and columns, because we wanted to have the effect of creep in these walls explicitly considered, so that countries who want to consider it can do it, and others who do not want to consider this can leave it. And we also wanted to have the partial factor, which is assumed in these provisions, clearly shown. Few words about annexes. I said materials, the ones we need for design, are in section 5, in clause 5. In Annex C, we give additional properties of materials which you do not need directly in design, but which are important for the performance of the materials so that our models apply. So just to give an example, for reinforcing steel, we define things here: minimum fatigue stress range for the reinforcing steel tested in air, or minimum relative rip area, and other things. So not used directly in design, but important to have our performance as given in the models. And similar things for pre-stressing steels and other types of components. Annex K, bridges. As I said, we expected to have few clauses, and in fact, it has turned out as we expected. Provisions given in clause 4 to 14 and Annex A to S, they apply all to bridges as well, except some very few clauses, and we have clearly identified those in Annex K and say shall not be applied for bridges. We have taken some of the provisions in current Eurocode Part 2 and integrated them into this annex here. You see them listed there: durability, serviceability, and so on. And we have added some new clauses, for instance, for external tendons and unbonded tendons, for cable stays, extra dosed cables, and bridges with suspension cables. And last thing I want to mention here on Annex K is we offer the option that national standardization bodies can give for bridges more restrictive provisions than for other types of structures. This is limited to specified topics in specific clauses which are listed in Annex K. And this was definitely intended to be used for provisions in the main clauses which are expressed as permissions. Now, this has caused some reactions, and discussions are ongoing on this, and perhaps I'm expecting 1 or 2 questions to this later on during the day. Annex M, lightweight aggregate concrete structures. That's basically the same content as in current Eurocode clause 12. But again, we have changed the presentation and give all these provisions again in a compact table. So you see immediately which clause, in which clause or table there is a change and exactly what the change is. Annex N, concrete structures using recycled aggregate. Also, this is new topic. Here we have created 3 categories. If you replace less or not more than 20% of the aggregates by recycled aggregates, we tell you you can use the provisions as they are given for the normal concrete. For substitution rates between 20 and 40%, we give you formulae or the properties in the table, which I will just show to you. And if you exceed 40% substitution rate, we recommend that you determine these properties by testing. For pre-stressed concrete, it's basically the same, but we do not have the lowest category where you can use the same properties as for normal concrete. You see again here the table where we give all these changes per clause where there is a change. So again, very easy to find and to implement. Annex Q, stainless steel, reinforcing steel, that's also new information. We recognize that the properties of stainless steel are different to the properties of non-alloyed steel, sometimes more, sometimes less. But we also found that at least for ULS design models, these differences are not really relevant. They are negligible, and therefore we permit, certainly for ULS, that you can use the same properties for stainless steel as you use for non-alloyed reinforcing steel, so the same stress-strain diagram. I'd like to highlight that we cut At the maximum strain, we cut for stainless steel at the same strain values as we specified for non-alloy reinforcing steel, even though stainless steel may have larger ultimate strain capacities. And we permit to use the same provisions for the same limits for fatigue as for non-alloy reinforcing steel if the steel complies with Annex C. I end with a few things. We have reduced the number of clauses where we refer to Eurocodes compared to today, but we have added new materials. So at the end, we have 101 clauses where we have introduced NDPs. We have reduced the volume of current Eurocode, but we have added a lot of new material. Definitely, in my opinion, we have improved navigation throughout the standard and ease of use. We also have prepared a very extensive background document which explains the main changes which we have made, almost 900 pages. And of course, through things as done here with the monographic issue and the conference today, a lot of additional information on the background to these changes will be presented to you. Formal vote has ended in the end of June, and both standards, Part 1.1 and Part 1.2, have been approved. And as I said, we expect publication or the availability from CEN any day now in October. I'm convinced we have now again a very up-to-date standard which covers a sufficiently wide scope and provides sufficiently simple rules for design of new structures, but also gives sufficiently advanced models for verification of existing structures so that we can avoid unnecessary strengthening. And I'm very happy that we were able to introduce some topics which will improve sustainability of concrete structures. Thank you for your attention.
Thank you very much. As you can see in the program, we have a short time for questions and answers after the invite conferences. So the floor is open. To participate, we have 2 microphones, and if someone wants to start intervening. Well, at least I have in my role to ensure that the question and answer will progress. I have at least 2 comments, but only one in case there are other comments in the room. What is your expectation about this concept that is going to be presented later on again by José María Rieta on the green concrete, with the possibility to use the 91 days of the strength? I remember that when this issue was open in our subcommittee, there was a kind of, let me say, revolution. But then during the last 3 years, no revolution at all. So do you expect some new applications and some possibilities to use this type of concrete that need to wait more days in order to get the appropriate strength?
I believe it is a concept which has benefits. I mean, you have to look at we have different types of concretes. I mean, if you look at the strength development, we have certain types which have a very rapid development and then they almost stand still. So for these concretes, there is not much interest in this concept, but we have other concretes which have a relatively slow strength development, which continues over an extended period of time. And those are often, or at least in the past, these were often concretes, so-called green concretes, which had the better sustainability values, CO2 footprint, and so on, than the traditionally used concretes in the past. And for those, I believe that concept will bring something, because between 28 days and 91 days maximum, you can gain 10–20% of strength, I would say, which you can exploit in many structures, because the design load often comes quite late in the life of the structure. Of course, you will have to look very clearly at stages during construction. You have to check those as well. But if that's fine, then I would say that concept should bring some benefits to me in the future.
Sorry, there is a question in the chat. Are there any further developments in the discussion of the stress ratio of pre-stressing steel above 1.1?
Yes, I had it on the slide, but for time reasons, I have not commented on it. You may have seen for the pre-stressing steel, we have this stress ratio, which is the tensile strength divided by, you can say, the yield stress strength of the pre-stressing steel. This is defined as 1.1, a value of at least 1.1, which is identical to what we have as a recommended value in the current Eurocode. But in current Eurocode, it's an NDP. But when we checked all countries in the current Eurocode, all countries adopted the recommended value. And therefore, we said no need anymore for NDP if everybody uses the same. So we made it a value, a firm value without NDP. And this has now caused some reaction because people found that some pre-stressing steels do not, which are on the market, do not reach that value. So values can go down to 1.08 or perhaps even a bit less. Now, this value of 1.1 is very important to us because it is important so that we can have redistribution of action effects in the members if we want or if we need it for ultimate limit state design. So this value of 1.1 ensures that we do not have a localization of all the deformations in only one section. So yes, there will probably be some more discussion on this, but I mean, I don't see much room to go away from such a requirement because, I mean, we rely on this redistribution capacity. This is a wonderful property of reinforced and pre-stressed concrete. And I certainly would not want to give that up because of certain production methods which result in lower values.
Thank you very much. Oh, I am happy now. So, sorry, micrófonos en la tercera fila. Pilar Crespo, levantas la mano, Pilar, para que te vea. Y luego en la cuarta fila, Alejandro. Pilar.
Good morning. My name is Pilar Crespo from the Ministry of Public Works. You have said that in Annex K opens the possibility to more restrictive provisions of the clauses in the main text. I have understood that this is mainly for the may clauses. So my question is about buildings. Is it possible to specify more restrictive provisions in the national annex for buildings in the main clauses?
No, not foreseen, not foreseen. The issue, I was expecting a question. The issue is, according to the rules on how to write the Eurocodes, that the rules say may clauses, the countries or any designer can use alternative methods if they can justify. The problem, another clause or another instruction says you shall not contradict the Eurocode. And the problem is if we give a permission to do something for buildings or for bridges, if somebody says, no, I do not allow to do this, I want less, then it's creating a contradiction to the Eurocode. If I say you can use, always my simplest example, you can use all provisions for bars up to 50 millimeters. This is what we say in clause 5. Then a country cannot normally say, no, in my country only 32, because it would contradict the Eurocode. The request was specifically made by bridge authorities in some countries that they want to use more restrictive rules. And therefore, we intended to introduce these provisions for bridges only. And as you say, the intention was to limit this to may clauses. Now, we have not written that so clearly in the Annex K, and that's why we will have to do some work there. But the intention was clearly to limit that option to bridges. You can always go outside in may clauses, but if you restrict more, then normally you would contradict the Eurocode, and that's why for bridges, because it was a specific wish, there we permitted it.
Thank you, Hans and Pilar. There is another question. Alejandro Perez.
Yeah, so it's been a long process, right? More than 10 years. And I was, of course, we had a lot of resistance to change, especially in the beginning. So I was wondering, what would you say was the most difficult part? Because, I mean, making so many different, let's say, having so many countries agreeing on the text is a bit of a miracle. So I would like to know what you think was most difficult.
Yeah, I mean, thank you for that question. I mean, we had, as you say, we had many years where we discussed, and I remember we had on a number of topics quite heated discussions. Before I go into any of these details on which ones, but I clearly want to say we had an excellent team. I must say, at the end of this work, we had an excellent team, and we really could have very good discussions. We shared. It took sometimes longer, but we found on many of these topics, we found at the end some way that most of us could live with it, or most of the countries could live with it. So what has caused a lot of discussion was the ETA-CC, for instance, the design strength of concrete, this concept to consider the increased brittleness on the strength side has caused a lot of reactions, where in particular countries who currently use alpha CC equal 1.0 feared that they may in the future be forced to look again at existing structures, whether they're still safe. Now, that was one of the topics, we can discuss a lot on this. Then another topic which has given a lot of discussions and initially very strong opposition, but then moved ahead, was the durability, the new durability design concept with the exposure resistance classes. That took quite a long time and a lot of discussions, but again, I'm very happy to report that solutions were found. The actual transition into practice with a connection to EN 206, that's still ongoing, but I'm convinced we will find ways there. We can start a bit conservative and then improve as the more knowledge we gain. So I would say from topics, the third one, of course, I have to mention is shear and punching. Also there, we have made quite a lot of or significant changes to members without shear reinforcement. Also, this has given very extensive discussions. And again, there was very good exchange in the task groups and in the working group to really look through all these proposals and at the end to come to a consensus where, again, most of the countries at the end could say, yes, with this I can work and I can live with it. So tough sometimes, but very good process. And I believe, as I believe was said at the start, people talked a lot about no revolution. We want just changing errors. And at the end, people felt comfortable with having new tools available and which will help for the design of structures in the future.
Thank you very much. Is there any other question? Well, I have another, I am a bit concerned about the collapses during the last years of bridges, buildings, etc. So my wondering is, do you think that the present provisions for robustness in our part 2, Eurocode 2, together with other Eurocodes are enough in order to face the situation of progressive collapse?
Tough question. I mean, we have a certain number of provisions which are, the ones which are specific provisions for robustness are mainly aiming at the buildings. We have something on the bridges for the minimum reinforcement there as well. My personal feeling is I would expect there more the engineer working on a specific structure to really think of things can happen and look at the detailing of the structures. I'm not how should I say, not particularly strong on that we need a lot more new clauses in our codes. I believe the code as we have is good. But certainly what's important is that the structural engineer is not going through that code like a textbook and just thinking, I have done this, I have done this. Really think when you read it, think and look at your structure, and think of what could happen to your structure, and then use the tools which we have given to verify whether things go as you would want to go them, and not causing something which is a dramatic, unexpected collapse or something. So rather focus on training at universities, as we have here, and use these tools which we have given in a clever way.
When I was associate professor, have a way to get some questions is just to be silent during some seconds and to be close to the attendees. But here we are very adult people. And so I have at least a last question, a last comment that I would like Hans to highlight. Having in a workshop in Italy recently, I'm making a presentation of Eurocode 2 and the third generation of Eurocode. They said, oh. So, and even in this country, having now the second generation, because you have not said something about the publication of the EN, but could you highlight the relevance of having this consolidate, accepted information that is today or in a few days going to be available for all the engineers in order to use this approach if they want, even if the process to get the national translations, the national annex will take some time. Do you think that is because some people say during the review of the magazine journal, they said it's too early. Still, the EN has not been approved. Finally, it has been approved. So, do you think that is an interesting fact to have this EN? So, or is this European bureaucratic process?
I mean, first of all, I can really say, I mean, the process of discussing all these things with all these many countries involved and these many experts, that was a very fruitful process. And I'm convinced we have reached a very good state of knowledge, which has been documented in these standards. I mean, to me, that is the state of the art of today, which has gone through an extensive discussion. I mean, we have had, as I said, in all these committees, we have had fights and discussions, tough discussions, but it has really helped to make sure that what we've put in fits together and corresponds to what we know today and can be used safely. Now, what you do and how quickly you implement it in the country, of course, that is the national choice. I mean, in our countries, we will now start immediately with the development of the national annexes for the NDPs. I can also say my personal impression for our country. I expect that we will take the large majority of the recommended values which are in the Eurocode as approved. We will adopt those because they have been extensively calibrated during this process. And again, I believe we found a good consensus. So I foresee for our country a relatively low amount of work to be done to look at some of these parameters. So I believe these new generation Eurocodes with the national NDPs can be introduced in the countries quite quickly.
Thank you very much, Hans.